In continuing our discussion of linear voltage regulators, we're going to turn our attention to IC voltage regulators. And of course, here again, IC stands for integrated circuit. And so, like we mentioned previously, our IC regulators are going to be a simple and cost-effective alternative, so simple and cheap, compared to building a circuit from scratch. So, compared to circuit from scratch, and so that would be, of course, like, for example, our discrete circuit that we analyzed in the previous videos. And so this is true for most applications. In some special cases, you might want to use a discrete circuit. So typically, our voltage regulator ICs are going to come in a packaging as shown on the left of the screen here. So you can see one example of such a voltage regulator is the LM7805. So of course, the display might not look exactly like that, but I've just written the numbers over the case there. And so typically they come in this special packaging, which we can call TO220 packaging. And so what we have here is that all of the gray areas in this drawing are metal. So of course we have our 3 pins on the bottom. And so on the left, we're going to have our input. In the middle, we have our ground. And on the right, we have our output. And then this metal up here on the back, if we were to flip this device over, we'd see it actually extends along the whole IC. And what that is to help with heat sinking. Because typically, as we talked about, our linear voltage regulators are going to be absorbing more power. So having this external heat sinking ability is oftentimes useful. Okay, so how do we go about connecting this to a circuit? Well, it actually depends exactly on what we need. Sometimes it's as simple as just hooking up our input to our input terminal. Where we want our output, we connect our load and grounding the middle one. We'll see in an example in our next video about how we can play around with that when we want different output values. But sometimes we might also need to include capacitors. And so we can look at a particular data sheet and determine based on what we want to do whether or not we need capacitors. So sometimes we might want to include capacitors between our input and ground. And so what that's going to do is help filter out any noise that's coming in from our supply side. And so the data sheets are going to help you sort of size that based on which voltage regulator IC you're using. We might also include a capacitor between our ground and output. And so what that's going to do is help improve our transient response. So this is improving our transient response. And so let me come back up here and put this in writing. So this one is typically going to be filtering our input signal. And so again, the data sheet for the particular IC is where you want to go to find that information. A couple other notes about using these IC regulators. So many of these IC regulators are going to have some type of current limit function. So IC regulators have some type of current limit. And so of course that's good because you're reducing a risk to the load, to damaging the load, and of course the IC itself, because we don't want excessive amounts of current to come through there and fry our circuit, and then all the magic smoke leaves and it doesn't work anymore. So that is good, but it's also still a good idea to include fuses and circuit breakers when necessary. So basically don't count on this. It's good to have redundancy in terms of safety. So fuses and circuit breakers are going to be a stronger sort of safeguard against high currents. But depending on your application, it might not be necessary. Again, this goes back to this idea of design. There's not necessarily one right answer for everything. Okay. One other thing to note about our IC regulator, maybe we have an application where this IC is in a breadboard, but our actual load is on the other side of the table, or maybe it's on the other side of the factory floor. So if we have a really long connection coming from wherever our voltage is, so let's say maybe we're trying to measure our voltage, switch to a color here, maybe we're trying to measure the voltage over here, and maybe this is some distance away, so we're connecting that to the output, and let's say maybe this ends up being like 10 meters of cabling, so it's a really long cable. And so of course in that type of situation we could have voltage being dropped across the cabling. In most of our circuits classes we assume we have zero voltage drop across wires, we assume they're ideal conductors, but in the real world that's not the case. So in this type of situation, some of these ICs have remote sensing abilities, remote sensing capabilities. Of course that's going to require some extra connections or extra considerations, but in some cases that might be necessary. So remote voltage sensing is something that might need to be considered depending on load proximity to the IC. So that's all for our basic introduction to our IC regulators. In the next video, we're going to see how we can actually wire these up to be useful.